Hello everyone, my name is Emily Grace. I'm the Research Manager at Hive. I'd like to welcome you today to our first ever Flow Research webinar, and particularly welcome to those of you who are joining us online around Australia and internationally. You should now have video of Pauline and I, and this is a great time to adjust your audio settings. We won't be taking questions during Pauline's presentation, but there'll be an opportunity at the end to provide your questions via the Q&A options in the webinar at the bottom of your screen. So I'll give you another prompt for that at the end of Pauline's presentation. If we do have any technical difficulties during Pauline's presentation, we are recording this and we'll email a copy or a link to the video file to anyone who's registered for the webinar. If you don't get that and you'd like it, please just email me. So it is with great pleasure today that I introduce our speaker, Pauline Maria Ishi. Pauline is originally from the Sonoran desert town of Queen Creek in Arizona in the United States. Pauline's father ran an apiary of 800 hives for more than 30 years, and Pauline was involved in beekeeping from a very young age. Growing up on an apiary has actually had a significant impact on her adult life. After completing her BBA in Oslo, Norway, Pauline moved to her current location in Tokyo. She decided to pursue a master's degree in agricultural sciences after being accepted to the University of Tokyo. And it was her professor, Kai Miyazawa, who introduced Pauline to the Japanese honeybees. The similarities and differences in beekeeping with Japanese and Western honeybees piqued her interest and led to her master's research project on the applicability of the flow hive to native Japanese honeybee, Apis cerana japonica. Pauline has continued with this research topic as a PhD candidate at the University of Tokyo, and is further investigating the use of flow technology in beekeeping with Apis cerana. So I'll hand over now to Pauline.
Okay, thank you for the introduction. Okay, so today I'm going to be presenting about the flow hive and Japanese honeybees. So first, let's just go over just a little bit the overview here. So first, I'm going to talk about the differences between Apis cerana japonica and Apis mellifera. And then after that, I'll talk about the Japanese beekeeping industry. And I will also talk a little bit about the traditional Japanese beehive. And I'll discuss my master's research and also how this has led into my PhD research. So first, just a brief history about beekeeping in Japan. So originally, so beekeeping has a long history in Japan. And originally, there were only Japanese native bees in the country. However, so as you can see here, with the Japanese honeybees, they were kept in close proximity with people. However, this has changed. The Western honeybee was introduced in 1877, and along with the Western bee, this also brought new technology. And this had a very transformative effect on Japanese beekeeping. So if we take a look at the physical differences, you can see that Apis cerana are quite a bit smaller than Western bees, and also they're a bit darker in color. But the thing that I would like to discuss is the differences in their characteristics. So Western bees are domesticated, and also you're able to keep them with foundation frames. They have a foraging area of around 2 kilometers, and you can move them from location to location for pollination services. They also have a higher honey production compared to Japanese bees. So Japanese bees are wild, which means that you cannot purchase Japanese bees and you cannot breed bees the same way that you can with Western honeybees. Also, Japanese bees prefer to build their own natural comb, and they have a smaller foraging area compared to Western bees, about half the size of the area. And also, beekeepers tend to keep their hives in the same location, and they have a lower honey production. And they also have a tendency to abscond. This is a common characteristic in Apis cerana, and it's one of the challenges with keeping Japanese honeybees. So in a sense, the Japanese honeybee has become marginalized in its own country. But Japanese honeybees have some characteristics that Western bees do not. For example, as you can see in the picture here, you can touch the swarm with your bare hands. And also, they have been shown to be better at pollinating native plants. And they also have some adaptations to the Japanese environment that Western bees do not. They have a higher tolerance for colder weather, and they're able to forage later into the autumn. And they also have a natural defense mechanism against the Japanese hornet, as you can see here. So there has been a resurgence of interest in keeping Japanese honeybees. For example, there's the Ginza Bee project in Tokyo. Sometimes they're able to keep Japanese bees in addition to the Western bees. And there's been an interest among hobbyist beekeepers. So if we take a look at the Japanese beekeeping industry, so if you look at the line down here, this shows the production rate. And if we look at the consumption rate, we can see that there's a huge gap between the supply and demand in Japan. So before, all of the honey used to be produced only by Japanese bees. However, this has changed dramatically. And if we take a look here, 10% of the honey, around 10% is produced domestically. And of that 10%, only 10% is produced by Japanese bees, which means the overall honey produced is less than 1% by native bees. But it's important to think about not only Western bees when we talk about protecting our pollinators. We also need to think about biodiversity. It's not wise to rely only on one pollinator, especially since Japanese honeybees are better adapted to pollinating some of the native species in Japan. So now let's take a look at the traditional Japanese hive. So as you can see in the picture here, it's a very simple setup. So at the bottom, there is some type of hive stand typically, and then there are some boxes on top of that. So these are the dimensions of a traditional Japanese hive. It's about maybe 2/3 the size of a long straw hive. So it is substantially smaller. And if we look inside the box, there's basically nothing inside because the bees like to freely build their own comb. And you can see here that there's a wire cross, and Japanese beeswax tends to be a bit softer than Western bees. So this support helps to keep the comb from dropping down during the summertime when it's hot. So if we look at the way how beekeepers add boxes to a growing colony, we can see that actually the beekeepers add boxes from the bottom. And so the reason for this is because Japanese bees tend to build their colony downwards. So as the colony grows, you just keep adding boxes. And then when you want to extract some honey, you remove the top box. And then you continue building, adding boxes from the bottom. So if you look at some advantages of the traditional Japanese hive, it's very inexpensive to construct. And also, it doesn't take a lot of skill to construct. And it also mimics the natural nesting habitat of Japanese bees. Some of the disadvantages are you're not able to control the swarm. You cannot split the colony, and it's not possible to combine colonies together. And you can only collect honey. You cannot collect honey from several different flower sources. And also, there's less honey production. So some of the points to think about when keeping Japanese bees. One is the characteristic of absconding. Also, when you're keeping bees in a traditional Japanese beehive, you have to take into consideration the honey extraction timing and also the amount of honey that can be extracted. And that's where the flow hive comes in. For my master's research, I wanted to see if the technology of the extraction of the flow hive would be possible with Japanese bees, since when you're extracting with the flow hive, you don't need to disturb the bees during the process. So the first step with my master's research was first testing out whether or not the flow hive was even compatible with Japanese bees. So there were some concerns that the beekeepers voiced. One of them was the overall size of the flow hive. The original flow hive is substantially bigger than a traditional Japanese hive. Also, they were worried about plastic. Japanese bees have an aversion to plastic. And also they were concerned about the flow frame cell size. So the flow frame's cell size is 5.8 millimeters, whereas Japanese bees typically build a cell size that's around 5 millimeters. So there were 5 participants in my master's research, and 3 of them considered themselves to be professionals and 2 of them were hobbyists. And of these 5, 2 were able to successfully extract honey. And if we look at these 2 cases, one of the keys was covering the flow frames in beeswax. And the purpose of this was to mask the plastic smell and also to help shrink down the cell size. So the beekeeper's feedback was to reduce the size of the flow hive by about 2/3, reduce the size of the flow frame, reduce the size of the flow frame cell size, and also to change the material of the flow hive box. So I took all of their suggestions on board as much as I could for my PhD research. And the theme for my research now is looking at whether or not the flow hive helps to reduce the tendency of absconding with Japanese bees. And I also wanted to see if there were any other benefits. For example, if the beekeepers like the technique for the honey extraction, and also if they would be able to extract more honey than normal. So for my research, I had 140 half-size flow frames, and I painted all 140 of those frames with a Japanese beeswax. And so each hive was given four flow frames, and I was comparing the flow hive to a traditional Japanese hive. So there were participants all throughout Japan, so you can see all the way from down here in the south, all the way up here to the northern part here. However, there were some challenges, unfortunately. So one problem was funding, and another problem was trying to figure out what type of hive would be most suitable for Japanese bees with the flow frames. And also there was a delay in the box production, which of course led to a delay in box shipment. So in Japan, I mentioned that it's not really possible to purchase a colony. So you have to really take into consideration the bee swarming timing. So this here is a map showing beekeepers who reported when they experienced a bee swarming. And so this is typically between March to May. If you miss this window of opportunity, it's very difficult to establish a colony. So unfortunately, the boxes weren't shipped out until June, so we missed this window of opportunity. And I want to discuss the initial prototype and some of the problems that we had with it. So this was developed by one of the original participants. He's a professional beekeeper, but there were some challenges, and the biggest thing was it was just too complicated. So if we take a look at the design, you can see that there are 3 long straw frames running down the middle. So these frames were turned to their side. And the reasoning behind this was so that the cell orientation would match the flow frames. And also, he recommended using a queen excluder in the areas that are marked in red. And also in the bottom box, there were plastic frames. But the good thing from this is that we learned which points to avoid. And also some of the beekeepers took it upon themselves to either modify the prototype, or they actually just used a traditional Japanese hive. And of these three participants, 2 used a hive without frames, and 1 used a hive with frames. And 1 beekeeper modified a long straw box. So I want to first discuss the beekeeper in Kumamoto. So this is Mr. Miyazaki. He actually shared his story on the Flow forum. So this is a picture of his prototype in his garden. And the way that he set it up was like this. So as you can see here, these are the flow frames. And these frames on the bottom are half-size plastic frames with foundation. So the first step he took was to put the plastic frames in the top box. This meant that the bottom box was empty. So in the second step, he let the bees enter and settle. And then after the bees had settled and they had filled all of the frames with honey and brood, he then took the frames from the top box and transferred them into the bottom box. And he placed the flow frames on top. And he was able to extract honey about 8 times from his hive. Now let's take a look at another beekeeper who's located in Nara Prefecture. So this is Mr. Noguchi, and there's a picture of him with his traditional hive with the flow frames on the top there. And as you can see here, he didn't use any frames in this box. He had a colony that formed a natural comb inside. And so what he did was, after the colony was established, he placed a box on top with the flow frames. So you can see this is a very simple diagram. We have the 4 flow frames on top, and then we have the traditional Japanese beehive underneath. And so this is a picture taken about 2 weeks after he had put the flow frames. And as we can see here, he already had some honey. And then after another 2 weeks, he was able to extract honey. So it took about 1 month for him to be able to successfully extract honey from his hive. And he also shared his story on the Flow forum. So from the beekeepers that initially participated, 7 of them were able to successfully confirm that honey was placed in the flow hive. And of those 7, 6 were able to successfully extract honey. And these beekeepers partook in a survey, which I will discuss now. So the first thing I wanted to look at was, of course, whether the bees absconded or not. So they said that with the traditional hive, around 28 or 29% absconded. Whereas with the beekeepers that reported honey being placed in the flow hive, none of the bees absconded. And if you take a look at the number of honey extractions, so if you look at the traditional hive, the majority only extracted 1 time. And about 43% were able to extract 2 times or more. If we take a look at the flow hive, we can see that the majority of them were able to extract 2 times or more. So you can see there's quite a big difference in the number of times they were able to extract. But I also wanted to look at the amount of honey that they were able to extract. So if you see here, this darker bar, this one shows the flow hive, and then the lighter bar shows the traditional hive. So the point I want to highlight here is that these 2 beekeepers, they were able to extract a significant amount more of honey. So if we take a look at the beekeeper number 2, you can see that he was able to extract 2 times as much honey compared to his traditional hive. And if you look at beekeeper number 6, we can see that he was able to extract 3 times as much. If we take a look at the beekeeper in the middle here, number 4, he was able to extract about 30 times as much. And the thing that they all had in common is that they used the traditional hive with the flow frames. Let's take a look at the other beekeepers. So these 3 beekeepers, they modified the initial prototype that I mentioned. And as you can see, with beekeeper number 1, he wasn't able to extract any honey from this hive. And then the other 2 beekeepers, as you can see from the graph, it was significantly less compared to the traditional hive. So I think that is, from these preliminary results, it's clear to see that the most successful cases were the traditional hive with the flow frames. So some of the key points to keep in mind: we need to make sure that before you place the flow frames on top of the colony, you need to make sure that the bees have sufficient brood and honey stored. And I also talked to the beekeepers about what are the benefits of using a traditional hive with the flow frames. So one of the benefits is that the traditional hive is in widespread use in Japan. This means that using the flow hives, it's very easy, and they don't have to purchase a new box or make a different type of box. Also, it's very cost effective. Most beekeepers in Japan, they tend to make their own boxes, and the cost of material is relatively inexpensive. Also, some of the beekeepers reported that they liked using the flow frames with the traditional hive because they said that the flow frames were more robust against waxworm. Also, the beekeepers were happy at the possibility of being able to extract honey more often. And also, they reported that they feel that the flow frames actually help to encourage higher honey productivity. And the reason for this is that when you extract the honey, this sends a signal to the bees that they need to replace the honey that has been extracted. They are also happy that they could control the amount of honey that they extracted. They could just extract one frame if they wanted to, as opposed to having to remove the entire box to extract honey. And also, they thought that it could be a way to control the colony size. So the more often that you extract honey, this would help to prevent the colony from growing, which could also help prevent swarming. So the next step is to take these preliminary results and to apply them to next year. So from spring 2019, I'm hoping that we'll have more participants be able to successfully partake in this research. I'd really like to have a larger sample size in order to test out the findings that we've had so far. So hopefully that will be possible. So thank you.
Thank you, Pauline, for an incredibly interesting seminar. We will take some questions now, and if you are online, you'll need to go to the bottom of your screen and bring up the Q&A icon, and you can enter any questions. You'll need to type them into that Q&A section. And while you're doing that, I'll just ask, are there any questions from here in the room?
Well, I've got one just generally about Apis japonica. Like you said, it's a wild bee, but have there been attempts to domesticate it and improve the strains? There's
a question here from Stu, who is asking, although Apis japonica is a wild strain, have there been any attempts to domesticate Apis or improve it?
So I think there have been some attempts to domesticate the bee, but they haven't been able to do so. And also, in regards to improving the strain, there isn't much research from what I've heard about this topic. So one of the problems is that it's not really easy to graft queen bees. So I've talked to some beekeepers who have tried to do this, but they haven't been able to. And what they'll actually do if they want to split a colony or if they want to replace a queen bee that has died, they'll look in other colonies and see if there are any queen cells. And then they'll take that queen cell and place it into the colony. But as far as grafting, like how you can with Western bees, it's really, really, really challenging. So, but I don't know the reason why it's so challenging, but I just know that beekeepers who have attempted haven't been able to do so.
Did that answer your question? We do have a question here from a listener. Did you want to read this out, Ian?
This is a question from Don Anderson in Canberra. He asks, the traditional method is to add the honey super to the bottom. Did any of the flow users add the flow super to the bottom, or did they all add it to the top? And was there a difference in how the bees used the flow supers added at the top or the bottom?
Okay, so for the beekeepers that I spoke about in this presentation, those 7, they actually placed the flow frames on the top. And the reason for that is because if you place the flow frames on the bottom, then the bees will put the brood inside there. There was one beekeeper who did attempt to do that, but the bees absconded.
So I'd just like to ask another question around that. You took out the queen excluders, and did you notice any brood being stored in the top box?
Now, if the colony is already established and if they already have brood and honey stored inside the traditional box or whatever method it is, they didn't report any brood being placed inside of the flow frame. So I don't think it's as big of a concern if they already have brood established and honey stored. So,
okay.
I guess my limited experience with Sarana has been in Indonesia. And I think the absconding is to do with parasite load and pest load in the colony. And there seems to be a natural way of the bee absconding when that load, and the European honeybee does exactly the same thing with hive beetle and a number of other pests that get in there. Is this a big issue in Japan? Is there other varroa mites there which are on Sarana and other areas, or Tropholaps?
Can I relay that? Yes, okay. So David Lloyd from Southern Cross University has asked a question here, and it relates to the concept that in PNG he's experienced Apis cerana absconding in relation to disease load or parasites. And so the question is there any evidence that is at play with Japanese honeybee?
oh, definitely. I think that absconding is their natural defense mechanism, because unlike Western bees, they don't produce propolis to protect themselves against viruses. So I think that's the reason why Japanese bees abscond. Right now, and your question about the disease, I think the biggest problem is a tracheal mite. So right now, there's a lot of research going on about tracheal mites, and the tracheal mite was transmitted to Japanese bees from Western beekeeping. So I think right now, some of the beekeepers in my project, they actually reported that this is a problem. And a lot of them are doing treatment to try to minimize the impact of tracheal mites, but that can definitely make a colony abscond.
I have a question related to pollination by the native Japanese honeybee. Mm-hmm. You mentioned that it is a better pollinator of native species. Mm-hmm. And I just wondered, has there been what is the evidence for that, and what is it, do you think, about the Japanese bee that makes it different in terms of pollination?
So there is one paper that I have read about the effects of the Japanese bees pollinating native plants. And they say that since Japanese bees are smaller, they're a little bit more nimble at pollinating those plants. And also Japanese bees have a much smaller radius when it comes to their foraging area. So even though the radius is smaller, they think that might influence the way how they actually pollinate. It makes them more efficient at gathering nectar.
And is that particularly native plant species, or do they find that in orchards as well?
In orchards, I don't know. I just know about with native species.
Okay. Do we have any more?
Maybe it's come in on the chats. Can we look on the chats?
Yes,
Thank
we have
you.
a question from Andrew. Excuse us. We have a question from Andrew in Melbourne. He said, I enjoyed the presentation. He missed the beginning. How many Japanese beekeepers use mellifera versus Serrana? It's related to the number of beekeepers in Japan using the different
I think
bees.
the majority of beekeepers, maybe the number of beekeepers keeping Japanese bees and Western bees isn't that different, but the number of colonies is different. So beekeepers that keep Japanese bees typically have only 2 or 3 hives at the most. That was one of the challenges with this project. It wasn't really possible to find a beekeeper who had a large apiary with just Japanese bees. So I don't know the exact number of beekeepers in Japan off the top of my head.
Another question here.
We have another question from Don. Is there a market for honey from Japanese bees? And does that honey get a higher price compared to Western bee honey?
Yes, it is very, very, very expensive. So we were talking about this earlier. 1 kilogram is around, I guess, 100 Australian dollars. So it's very expensive. As far as the market goes, I definitely think that within Japan, there's a market, because I think that Japanese people tend to value quality. And also, I think that since it's coming from their native bee, there definitely could be a bigger market, but this is something that hasn't been tapped into.
Do we have any further questions? If you're online, could you please use your Q&A icon to enter any questions? We'll just see if any more come through.
We've got 12 people online today.
How big an issue is bee space with Serrana? Because, I mean, we know bee space in mellifera is critical with the flow hive. Is bee space having to be altered at all?
I think so.
Would you like to repeat the question as part of your answer? Oh. So the question relates to bee space being important in mellifera. How important is bee space in Serrana?
Yeah, I definitely think that it's important. And that's one of the problems that we had with the initial prototype, was the bee space. I don't think it was taken into consideration enough. So the bee space isn't actually that much different from Apis mellifera, but you definitely have to take it into consideration, especially if you're using frames. So yes, it matters.
2 questions, Peter Detchen and then Patrick Anderson.
Okay. I have another question here from Peter Detchen in Western Australia. The flow frames used in these Japanese beehives, did they have a similar cell size to the flow frames that we're using for European bees?
Yeah, so the only difference from the flow frames that are used with European bees is the length of the frame. The cell size is still the same, so it's still 5.8 millimeters. So actually, that was one point that I was concerned about initially, but it wasn't problematic as long as you coat the flow frames with the Japanese beeswax.
And from Don in Canberra, is there a taste difference between the 2 types of honey?
I think that the taste of honey is dependent on the flower source more than the bee. So, but some people say that they can tell the difference between whether the honey comes from Japanese bees or Western bees. I think that it is possible, since the way that they pollinate is a little bit different. So I personally, I can't tell the difference, but maybe some people can.
Our Apis Serrana experts in the room have told us that they can. But I think that they must have tasted a lot of Apis Serrana honey.
Yes.
So I'll just acknowledge that in the room we also have Kazuo and Siaka Takeyasu from Japan. Thank you for coming all of this way to share this research with us here at Flow Hive. And Kaimi Azakawa, who is Pauline's professor and has supported this research project. We appreciate having you all here with us today and online to share this research. It's been incredibly interesting for us. We appreciate the opportunity to support this small or this boutique industry, I guess. There are a lot of passionate Apis cerana beekeepers in Japan, and I think we've got some really interesting results. So we're really looking forward to how Pauline's research develops in the next season, when we actually have a full season and we have 35 flow hives to compare to the traditional hives, and continue to see how this research project grows. So thank you very much, and thank you, Pauline, for the presentation and for coming all this way.
Thank you for having me.